Let's delve deeper into the concept of even and odd. The concept is even times even is even. Even times odd is even. Odd times odd is odd. Even plus even is even. Even plus odd is odd. Odd plus odd is even. Even to the power of even is even. Even to the power odd is even. Odd to the power even is odd. And odd to the power odd is also odd. A very basic concept, but some beautiful questions can be made on it. Let's warm up with some examples here. If p, q, and r are positive integers, and the product p times q times r divided by 8 is an integer, which of the following must be even? Now remember, must-be cases are those where you do not get a no even once, so the right approach in these questions is to try to get a no. The moment you get a no, you have an answer. Okay, please note this is not one question with 5 answer choices. These are 6 different questions, and the answer to each can be yes as well as no. One possibility is that only one of them is even. Something like this: p equals 8, q equals 3, r equals 5. The other possibility is that 2 of them are even integers. Say p equals 4, q equals 2, and r equals, say, 3. The other possibility is that all 3 of them are even integers. Something like this. Now let's play around. P plus q plus r. We have to look for just one case where no is a possibility. So yes, p plus q plus r is even. In this case, you can see 2 are even, 1 is odd, and therefore we can say that yes, there are cases where p plus q plus r can be odd. Hence, no. In this case, p plus q plus r must not be even. P times q plus r. Once again, see in this case, p times q would be even, plus r is odd. So again, we have a case. So we can use a no for this one as well. Use a no or a cross mark, whatever is intuitively easier for you. In case of this sum, a case where only one of them is even, see this case, p times q would be even, p times r would be even, but q times r would be odd. Overall, even plus even would be odd. So we can say no for this choice as well. For pq divided by r, there will be a lot of cases where pq divided by r will not be an integer on the first place. Something like this. See, pq divided by r is a fraction, so of course it won't be an integer in such cases, leave alone being an even integer. So here also, we can say that no, this is not even in all the cases. Next case. P raised to the power q raised to the power r. In cases where p is odd, for example if p equals 1, q equals 8, r equals 3, in cases such as these, you will see that p times q times r divided by 8 is an integer. But the value of this expression is odd, so even this will not suffice. Next case. P times q raised to the power of r. In combinations where p is odd, q is odd, and r is even, see pqr divided by 8 would be an integer, but p times q raised to the power r would still be odd and not even. So there is none of the 6 cases where the expression must be even. One key aspect that data sufficiency teaches you is to be open to all possibilities. So see 6 cases, but in none of the 6 cases, we can say that the value of the expression is definitely even, given this case to be true. In case you did not get all 6 correct, you have one more chance. In this, you will see that the condition that p times q times r divided by 8 is met, but figure out that pqr is even. So the base is definitely even. Now one may think that even to the power of odd is also even, and even raised to the power even is also even. However, there are cases such as p equals 1, q equals 1, r equals 8, where you will figure out that pqr would be 1 times 1 times 8 raised to the power p plus q minus r. 1 plus 1 minus 8 is negative 6. Hence, you will have 8 raised to the power of negative 6, which would be a fraction and therefore not an even integer. So even in this case, there are values which satisfy pqr divided by 8 being an integer, but the value of the expression not being even. So even this does not work. We have 7 cross marks. This was a must-be question. This was the concept, friends. GMAT shots are deliberately kept brief. For an elaborate explanation, please watch the Stage 1 conceptual videos in our program. Thanks for watching.